Hi everyone, welcome to Nanorush 2024. I am Siti Khadija from School of Physics USM. Today we are going to explore the science behind nanotechnology, the fascinating world of nanotechnology, and understand its profound impact on our daily lives. Now, have you heard of nanotechnology? Let's start with the definition. Well, in Greek, the word nano means a dwarf. So in general terms, nanotechnology means technology that has to do with small things. On the other hand, in science, nano also means a billionth. More example, 1 nanometer equal to 1 billionth of a meter. Now, to help us imagine nano size, this is a baseball bat, which is about 1 meter long. Now, if you take its length and divide it by 100, you get to the size of our fingertip, which is about 1 centimeter. Then, take that and divide it by 10 and you get to the size of a needle eye, which is only 1 millimeter. Take that and divide it by 10 again and you get to the diameter of a human hair, which is then 100 micrometer. This might be the smallest division you will be able to see by naked eye. Take that and divide it by 10 again and you get to the size of a human red blood cell, which is about 10 micrometer. Take 1 red blood cell and divide it by 10 again, you get to the diameter of a bacteria, which is only 1 micrometer. Take 1 bacteria and divide it by 10 again. You get to the size of a virus, which is around 100 nanometer. Now, if you are in the scale of a nanometer, all you have to do is to take 1 virus and this time divide it by 100 and you get to the size of a half of a DNA, which is only 1 nanometer. 1 nanometer, it means only 5 atoms sitting end to end. 1 nanometer, 1 billionth of a meter. Now, we know how small it is, right? But when does it all started? Who introduced the concept of nano? Richard Feynman, the American physicist and a Nobel laureate, introduced the concept of nanotechnology in 1959. He described a vision of using machines to construct smaller machines and down to the molecular level. This new idea demonstrates that Feynman's hypotheses have been proven correct, and for this reason, he is considered a modern nanotechnology icon. And after 15 years, Professor Norio Taniguchi, a Japanese scientist, was the first to use the defined term nanotechnology in 1974. He defined nanotechnology as nanotechnology mainly consists of the processing of separation, consolidation, and deformation of materials by one atom or one molecule. In previous years, in 1857, Michael Faraday discovered colloidal ruby gold demonstrating that nanostructured gold under certain lighting conditions produce different colored solutions. When materials become smaller and smaller, the physical and chemical properties change dramatically. The best example is the gold ring on your finger, which is golden yellow in color, but a gold nanoparticle is not necessarily golden. It can be red, purple, blue, or even green. This is called quantum effects. And since the science are rapidly growing, the first scanning tunneling microscope (STM) was developed in 1981 by IBM physicists. This microscope used for imaging surfaces at the atomic level. This invention gave rise to the field of nanotechnology and also in modern electronics. For example, the computer's evolution. The first computer in the world was invented by Charles Babbage between 1833 and 1871. He developed a device, the analytical engine, and worked on it for nearly 40 years. It was a mechanical computer that was powerful enough to perform simple calculations for specific ballistics problems and not to be a general-purpose device capable of solving any problem. In 1971, first personal computer introduced by IBM brands. This time, they have keyboards, and Sony introduced the first 3.5-inch floppy drives and diskettes in 1981 for general users. Then, in 1981, the Apple company invented the first generation of Macintosh. Then, in late 1980s, the personal computer upgraded. They have bigger screen and memory and have more function with softwares. Further evolution occurs when iMac G3 was introduced in 1998 by Apple. This unit combines all-in-one where CPU and monitors with CD slots included. In the year 2000, the desktop computer industry was rapidly growing and the design became more compact, slim, with high-resolution flat monitor screen and more. Around year 2000 also, while technology was rapidly advancing, tablets and thin laptops began to appear on the market. More memory, functionality, speed, Wi-Fi, a good camera resolution, and more are all included. Why does scientists really into this nanotechnology? Because nano means smaller in size, but has huge impact. Because the smaller size of the nanomaterials give higher surface area. How is that possible? Now, to visualize that, let's say we have a cube and the length, width, and height of 20 cm. Now, what happens to the cube surface area if I divide it into 8 cubes? The surface area becomes 2 times larger. You see, I'm not changing the material, neither its mass or volume. I'm just creating more surfaces, so the available surface area is double. Now, imagine that I divide it again until the length is 2.5 cm. The surface area becomes 8 times larger. And further divides will make it 1.25 cm in length for one small cube. That makes the surface area is 16 times larger from the original 20 cm cube. If I divide each of these cubes into smaller and smaller cubes until having cubes with 20 nanometer length, if I do that, we are going to have 10 million times larger surface area. Small material, small mass, same volume, but 10 million times larger surface area. In fact, this larger surface area is the keyword of high performance in nanotechnology. The large surface area is beneficial in many ways, includes electronics, for example, resistance, capacitors, storage that have higher performance, bigger capacity, although they're physically smaller in size. For energy, nanostructured solar cells are being developed to improve the efficiency of solar cells captured, making renewable energy sources more accessible and effective. The application in healthcare and biomedicine, for instance, nanotechnology is revolutionizing the way we treat diseases. Nanoparticles are used in targeted drug delivery systems, ensuring that medication reaches the exact area in need, reducing side effects and increasing efficiency. In environment, nanotechnology improves water purification, air filtration, and pollution remediation. It enhances renewable energy efficiency, promotes sustainable agriculture, and supports waste management. These applications help protect natural resources, reduce pollution, and promote environmental sustainability. Nanotechnology in the food industry involves in various stages of food production and packaging. It provides unique properties that can be used to improve food quality, safety, and sustainability. Also, application in textile. Nanotechnology in textile involve the application of nanoparticles or nanocoatings to fabrics, giving them advanced properties. This can include making fabrics water-resistant, stain-resistant, more durable, or even providing antimicrobial properties. Thus, nanotechnology are important to our daily basis, whether we are aware or not. It is all around us. How does the nanosize enhance the performance of devices? Let's see an example of solar cells. Now, when making tiny strands or nanoarrays of filamentary crystals shaped like this, it will make it more efficient in absorbing incident light. And it able to collect or pick up reflected light falling in the vicinity, so they can be sparsely located or thinly distributed. That means, in simple words, with nanomaterial, solar cell can be better capture and convert sunlight into electricity. Another example is sunscreen. When we apply sunscreen containing nanoparticles or nanocomposites, it will give more protection since it has more surface area to absorb the UV light. Thus, it gives more protection to our skin. Next example, we have coating. When a surface is coated, the surface tension is reduced and the moisture penetration is minimized. You can see the difference here. between with and without coating. And let's say we have a surface that coated with a nanomaterials, and that nanomaterial has an antibacterial effect. What happens is that when a microbe approaching the nanomaterial's coated surface, the surface will attach, penetrates, and ruptures the microbe. Eventually, the microbe is neutralized, and that is what we call an antibacterial coating using nanoparticles. On top of that, nanotechnology revolutionized drug delivery and medicine by enabling precise, targeted treatments. Nanoparticles can carry drugs directly to specific cells or tissues, such as targeting cancer cells while sparing healthy ones, which enhance treatment effectiveness and reduce side effects. Nanotechnology also allows for controlled release where drugs are released slowly over time, improving patients' outcomes. Additionally, it can be used in imaging and diagnostics, helping to detect diseases earlier and monitor treatment. Alright, in summary, nano is a billion. Nano size means smaller in size but larger surface area. Nanotechnology offers numerous benefits to humankind by enhancing various fields. Overall, nanotechnology drives innovation that improves quality of life and addresses global challenges. That's that's all from me. Thank you. Have a good day and all the best.